Nvidia should buy Tesla. We're making the case for this merger because there is a unique opportunity for both companies to literally take advantage of each other's assets and fill in the gaps that both companies have, because both companies have proclaimed the same goal, which is to become a leader in real world AI or robotics. And both companies have requirements that they could much faster fulfill by merging. Therefore, we suggest the merger between Nvidia and Tesla. In a nutshell, you can argue that robotics is a distributed computing problem. It starts with a robot and it ends in the data center. So you can't just separate the hardware, the robot, from the IT, which is the case today. The only company which is trying to combine everything is Tesla. They are actually a fully integrated, vertically integrated company that is doing as much software and as much hardware, and more importantly, hard engineering. That's what we call hard engineering, which is a new word that we introduced. And we introduced it to combine deep learning with hard engineering, which gets you to deep engineering. It's a new term that we coined and hopefully can proliferate going forward. This episode is meant to explain what deep engineering means and why this case for Tesla and Nvidia is so powerful. The main three reasons are: one, again, robotics is a distributed computing problem. Second, both companies, they lack each other's strengths. So if they combine, they can do it. And most importantly, third, is that the mindset of Tesla, which is to iterate and solve hard engineering problems at Silicon Valley scale. This mindset is not available anywhere else. So what Nvidia has to offer could potentially be replicated by companies in Silicon Valley, which is a data center infrastructure, a software-defined data center, AI-driven IT infrastructure. Those things could be potentially replicated, but the mindset of a hard engineering company like Tesla is very difficult. In fact, it's not replicable, and you can see that also at SpaceX. Starting Starship, destroying it, collecting data, learning from mistakes. All these things are novel approaches toward hard engineering problems, but that's in a nutshell how it can be done. The same applies to, let's say, the full self-drive stack of Tesla. Like, the one thing that Elon Musk has been able to do with SpaceX and with Tesla is to do research at the same time as he generates sales. And that's, one beautiful example is also the Starship, which now, hopefully, even the next test flight already could be a payload flight. So it could be a paid flight where they bring in a payload to orbit and then let the ship actually then explode afterwards, but they can collect data, learn from it, and also make money. So doing research while generating revenues is a massive, massive help and just accelerates everything. And this is, in a nutshell, what hard engineering is. Hard engineering is not the actual solving of engineering problems. I mean, there's no question that companies like Lockheed or Siemens or Hitachi or Cattle, anywhere in the world, there's enough engineers and enough smart people to solve hard engineering problems. But the way it's done at Tesla and at SpaceX, or the Elon Musk mindset, is that you're doing it at speed, at scale, taking risk, but you're also doing it in a sustainable way, so you can actually generate revenue while you're doing R&D. So you can do a lot more R&D, you can be faster, and you can also bootstrap yourself, which is really the great advantage, is to bootstrap yourself while you're learning. This is not In Wrong Podcast. It's March 23rd, 2024. This is Chris Delco. Since the last update, we are down 17.5%. The market is up 9.7%. We're underperforming by 27.2%. The case for Nvidia to merge with Tesla is very strong in our opinion, and it starts with the idea that both companies want to drive real-world AI. Why did I say idea? Well, it's not clear. I don't have 100% certainty that that's what they want to do, but from the statements of Elon Musk and Jensen Huang, that is what we infer. Jensen Huang gave a keynote at GTC 24 this week where he clearly stated that Nvidia wants to be the foundry of robotics. I'm going to parse that and dissect it and explain what it means. But for now, let's just say what Nvidia needs is a pipeline of software and hardware that can drive intelligent embodied decision-making agents. So this is what they're trying to achieve. And they're trying to achieve it in simulation and also, of course, in the real world. Now, NVIDIA's strength is in simulation, so that's where they're putting on their strength, and there's something called the Omniverse, which is sort of a unified software platform that allows all kinds of software teams to work together and exchange and work on digital assets, and then use those assets to generate simulations, and then from those simulations build foundation models that can be used sort of similar to large language models, but for multimodal foundation models, and they can be used as a base to train robots. So we establish first that there's a goal. Both are driving towards the same goal. Now, second, there are holes in both companies, or assets that are available and assets that are not available. So in a way, it's like a masked autoencoder where you have certain things available, but certain things are masked. So if you take NVIDIA, if you take the whole thing, what it takes for a real-world AI company to succeed, in our opinion, is you have to be a fully integrated, full-stack company, and the stack starts with a robot and ends with the data center. Robotics is a distributed computing problem. So if you take NVIDIA, you have, let's say, the data center, the networking infrastructure, the software infrastructure, the chip design, the chips. So all these things are given. But once you leave the digital world and you enter the actual hardware of robotics, which is the robot itself, the actuators, the IT on the robot, and the connection, the connectivity between the robot and the data center, there are holes that NVIDIA has. But most importantly, NVIDIA has one big hole, which is no matter how good your AI is, no matter how good your software is, you're not deploying it yourself, right? You depend on other customers to deploy it, and that's where you're dependent on their cycle, on their innovation, cadence, and that so far has not worked for NVIDIA. If you look at the data center business and the sort of physical, real-world AI business of NVIDIA, it's night and day. The data center business has been growing from hundreds of millions to tens of billions, while the real-world AI business, so in particular the automotive business or even the professional visualization business, so everywhere where they touch the real world, where customers are not Google or Facebook or Amazon, but companies like Siemens or Lockheed Martin and those types of companies, all of a sudden growth slows down massively. And the reason growth slows down massively is just simple because the cadence, the appetite for risk, the innovation on the physical side is not there. In short, if you depend on customers like Siemens or Daimler, nothing wrong with them. They just have their own culture, their own cadence, and they're not going to yield on that. I mean, they're going to stay within their capabilities. They're not just going to start iterating now at a monthly pace when they used to iterate at a yearly pace. That's just not what they're going to do. They can't do it, even if they want it. So that's the problem of NVIDIA. On the Tesla side, if you take the same scheme, you say, okay, if you want to be a fully integrated distributed computing company in the robotic space, you have to start with the robots, which Tesla has. They have the robot, which is the car. They know how to make cars at scale and low cost. They're in the process of learning how to make robots, humanoid robots, at scale and low cost. So the hard engineering problem is if there's any company in the world that can solve it, it is Tesla. So they can build cars at low cost again. That's really, really important. Cars that can last a long time, drive hundreds of thousands of miles, don't break, have batteries that can sometimes even defy physics, but certainly have exceeded any kinds of expectations in terms of what they can do in terms of range and charging speed and power density. So they've solved that problem. We believe that they will also be able to solve the robotics problem, which is, again, like things like actuators. Also, just make a robot that doesn't break, have a battery that lasts long enough. All these things are hard engineering problems. Then you have to connect that computer to a data center so the data center can collect the data and use machine learning technology to induce intelligence into the robot. And then you have to have an inference engine on the robot that can make sense of reality and act within the confines of the model. So that has been solved to some extent by Tesla, but Dojo is the idea here that Dojo fills in a big gap, which is the data center side, the training side. It looks like Dojo is a little bit on the back burner, and that's something that Nvidia can certainly step in and bring immediate acceleration. If you take the problem of AI today, on the technology side, it's how can we use transformer architecture towards other modalities, and how can we translate transformer architecture into the real world? Transformer architecture has shown to be incredibly powerful in generalization of reasoning, and robot is nothing but a machine that is reasoning throughout nature. And how can we take advantage of that knowledge that we have gained through the last couple of years, starting with the seminal paper, Attention's All You Need, and then going forward? That problem is being solved as we speak by Nvidia, by many researchers, and also by Tesla. We believe that combining Nvidia and Tesla will strengthen also the AI side of things, because fundamentally what's required here is rapid iteration. This is the most important thing. We have phenomenal ideas at Berkeley, at Stanford, at MIT, at Zurich, at Heidelberg, at Beijing, Shanghai, Singapore, and so on and so forth. The world's full of smart scientists. The world is working very hard towards solutions to problems within the real-world AI space. That's not the issue. But what people lack is the ability to iterate faster, to try models, to try hardware, to try both, iterate on both sides of things. And this is where this combination could yield massive returns. Because with a hard engineering company like Tesla and a deep learning expert like Nvidia, you could iterate on both sides at the same time. What kind of transformer architecture is best suited for multimodal reasoning? What should we use reinforcement learning? Should it be model-based or off? Should it be model-free or model-based? Off policy? Those are things that the researchers in the RL space, in the transformer space, are still debating. And it's the way research is done in academia is that you come up with an idea, and then you run an experiment, and then you have a benchmark, and you test it, and that's fine. There's nothing wrong with that. That's the best they can do given their budgets. But imagine if you had a real-world hard engineering company like Tesla that is embedded into a massive deep learning infrastructure such as Nvidia, and then you combine both, and you have this ability to iterate and learn much faster. This is, in a nutshell, the way we see the fruits of a merger like this. This is on the sort of knowledge creation side of things, but there's another important aspect, which is cost. Cost per unit of training, cost per unit of compute, cost per token, cost per inference. whatever you look at, in order for this to sustainably grow and bootstrap itself and get to industrial scale, we need somebody to drive down the cost. And Nvidia has been able to drive down the cost per training, per unit of training, per whatever energy consumption. All of these things are incredibly, they all look very good for Nvidia. That's why they're so successful. But where they fail, where Nvidia fails currently, is on the engineering side. So the cost per unit of compute when it comes to a software-defined warehouse or a software-defined car, they're still very high, and that's because the cost of the car and all these things are very high. So the company which is driving the cost on the hardware side, on the engineering side, is Tesla. And combining those two again, so the cost of the cost per token that needs to be generated for a self-driving electric car to drive can be driven down most efficiently in a combination of Nvidia and Tesla. So it's one learning, the other is cost. And I think the third factor which is important here is mindset. Mindset is something that I think the business literature, psychology literature, Silicon Valley, Wall Street, everybody talks about it. Everybody knows it's important, but nobody's able to quantify. Nobody's able to actually put a finger on it, and that's fine. I acknowledge that it's hard, but it's there, and we can't underestimate it. The reason companies like Tesla and SpaceX succeed in the end is because of mindset. And the mindset is the willingness to try and fail and make mistakes. It starts with the culture in the company. Reed Hastings, in his book No Rules Rules, says that culture is something that gets you promoted and gets you fired. That's what culture is. The culture at Tesla is to innovate and try new things and learn from mistakes. That's the culture. It's a very untypical culture for engineers. And in my opinion, that is the biggest breakthrough that Musk has been able to achieve with his employees, which is to have highly educated, smart people from prestigious universities willing to make mistakes and fail. This is the mindset that, in my opinion, also exists at Nvidia, maybe not at the scale, because what Nvidia already does is design in silico, which means you can fail as many times as you want. In silico, it costs nothing. And also there's no reputational risk. But if you make a car and the thing fails, you have reputational risk. If you make a rocket and it fails, you have reputational risk. When Starship goes up and blows up, I think there's still people that think this is a failure. They don't understand how important these types of iterative maneuvers are. I once spoke with the CEO of GitLab, and it just shows how important it is to talk to smart people. He told me that he was impressed when he went to see Tesla at Brownsville, SpaceX at Brownsville, how they're iterating by blowing up rocket ships all the time. And I thought to myself back then, yeah, this is just a small tidbit. So this guy went there and yeah, they're blowing up stuff. It happens all the time. But then I thought about it twice and I thought to myself, actually, no, it's just stuck in my head. Why did he mention this? And slowly but surely I came to the conclusion, the reason he mentioned it is because it's a whole new revolutionary way to do business. And this is the conclusion today, is that you need a hard engineering company is a company with the mindset of trying and failing and iterating fast. This is what hard engineering means, because this is the only way you can actually solve hard engineering problems. You can think about it as much as you want. You can think about it, you can hire the smartest Nobel Prize winning physicists and all of that. That's not what hard engineering means. Hard engineering means that you have a culture in place that innovates in a way like SpaceX and Tesla do. So to summarize, the combination of Tesla and Nvidia, in our opinion, is necessary to drive the speed by which real-world AI can proliferate throughout industry. It brings three important factors together. One is it brings two companies together that both have the same goal, but they come from different sides. One comes from hard engineering, the other from deep learning. Combined, you get deep engineering. And together with the fact that robotics is a distributed computing problem, this is the solution. Because second, both companies have holes. If you think about the stack from robot all the way to data center, networking technology, AI, model infrastructure, the whole compute stack is what makes robotics work. Then you have holes on both sides that can be filled through a merger. And third, and probably most important actually, it's the mindset. The mindset of a hard engineering company is very hard to replicate. Currently, the only company which has a hard engineering mindset and is also willing to drive Moore's Law is Tesla. And therefore, Nvidia should buy Tesla so they can combine their expertise in deep learning infrastructure with hard engineering. Thank you.